Okay, so here we will see about the half wave rectifier. So half wave rectifier means here you all know the function of the rectifier is to convert the AC into a pulsating DC, not a pure DC. Okay, so here this half wave rectifier construction contains a three main one. One is a step down transformer, another one is a PN junction diode, third one is a load resistance. Okay, so here see this is a step down transformer. So the function of the step down transformer is to reduce the input voltage. Okay, so if you want to increase your voltage means you have to use the step up transformer. Okay, so here your ultimate goal is to convert the AC into DC, right? So you have to reduce the voltage supply. That's why you are using the step down transformer. Okay, so while drawing the step down transformer, you should take care that here this number of turns should be maximum in the input side, that is a primary side, when compared to the secondary side. Okay, so in the transformer, primary is the input, secondary is the output. Okay, so the number of turns is maximum in the input when compared to the output. Okay, so you have to take care of that. Then this is the second one is the diode, PN junction diode. So you already known about the diode, right? So in the diode you are having a two terminals. One is a positive, so this is the positive terminal, and the second one is the negative terminal. Okay, so the positive terminal is also called as an anode, and the negative terminal is also called as a cathode. Okay, so this PN junction diode will act as a forward bias or reverse bias. Okay, so based on your connecting supply. So if it is a forward bias, then there will be a current conduction. If it is a reverse bias, then there should be a no current conduction. Okay, that is the concept, that is the function of the PN junction diode. See here, during the positive half of the cycle, this is the pure sine wave. So during the positive half of the cycle, when your input is entered, then this is the positive terminal and this is the negative terminal, right? So this positive is connected to the positive. So this diode is act as a forward bias and there will be a current conduction. Okay, see, so during the positive half of this wave, you are getting the wave. Why? Because positive and this diode is a positive. So when connected, positive is connected to the positive terminal of the diode, then the diode will act as a forward bias. Then here there is a closed switch, so that is the current conduction along this path. So you are getting the wave. Okay, similarly during the negative half of the cycle, if the negative half of the cycle is entered means this is the negative terminal and this is the positive terminal, right? So now in the diode this is the positive. So when the negative and positive is connected means that is the reverse bias. So under reverse bias there is no current conduction, so you will not get any output in the output side. See, this is the output waveform, you are not getting any wave, right? So this is negative, you are not getting wave. So only during the positive half of the cycle you are getting a continuous waveform like this. Okay, so this is the pulsating DC, not a pure DC. Okay, now clear? This is the half wave rectifier principle, construction and operation. So principle is what? It converts the AC into a pulsating DC only a positive half of the cycle.